So the last historical question that I wanted to ask was what role, I just mentioned him actually, what role John Bell played in the development of Bohmian mechanics?
First of all, he was the main advocate of Bohmian mechanics between, let's say, 1960 until his death around 1990. He was a primary advocate, almost the sole advocate. Well, there was Bohm advocating for it, but not with the eloquence and the clarity that Bell brought to the subject. Now, so there is that. There's also the fact that Bell established that quantum mechanics is non-local. In so doing, he did that by his Bell inequality argument. And the irony about that was that part of that argument involves proving that the EPR argument from 1935 that you mentioned, you've talked about various times, that EPR argument was an argument to the effect that the wave function does not provide a complete description of a physical system. There has to be more than wave function. Bell showed that that argument is definitely wrong. Not that the conclusion is wrong, but the argument is flawed. Because the argument assumed locality, the EPR argument. And the assumption of locality in that EPR argument led in the Bohm version of the EPR analysis with involving spin and not particles, not position and momentum, but the spin of two particles. The Bohm version of that argument, under the analysis of Bell, showed that version of the argument showed that the EPR argument in this version led to conclusions about incompleteness of quantum mechanics, the existence of pre-existing values for spin components, which were incompatible with the predictions of quantum mechanics, and incompatible, in fact, with experiment. So Bell showed that, in fact, the crucial assumption in the EPR argument, locality, has to be given up if the predictions of quantum mechanics, confirmed by experiment, hold. That was, or should have been, the main objection to Bohmian mechanics, that it was non-local. Bell, having shown that non-locality is indispensable, it's an intrinsic feature of quantum mechanics, removes the crucial objection to Bohmian mechanics. In fact, it converts the objection to a merit. After all, if Bohmian mechanics were local, it would have to be wrong. And Bell was in fact led to his Bell inequality and all that famous work by thinking about Bohmian mechanics. Bell asked the question when he was in a paper in the early 60s on hidden variable theories. He looked at Bohm's particular hidden variable theories, saw that while it worked, it yielded the predictions of quantum mechanics. He noticed that it had what he called the grossly non-local features. And Bell said, Bell said that while Bohm, he said, was well aware of these features, nobody has done an analysis of whether it's possible to do better than Bohm and come up with a hidden variable theory which does not have these non-local features. That was the question Bell addressed. Whether or not he tried to see whether it would be possible to come up with have a hidden variable theory which was completely local. And Bell proved that was impossible, and he proved more than that. Not only must any hidden variable version of quantum mechanics be non-local, he proved that any clear, serious version of quantum mechanics must be non-local.